To find the equivalent fractions, again, we're just going to multiply or divide by some same factor in the numerator and denominator. So in this case, I'm just going to divide. I'm going to divide by 2 and get 9 over 12. I can divide by 3 to get 3 over 4, and these are all equivalent fractions. Here we can again multiply or divide. Again, it looks like I have common divisors, so I'm going to simplify this to lowest common fraction, sorry, lowest terms fraction. So I'm going to divide by 3. So I end up with 11 over 15. These don't share any more common factors, so that is the fraction in lowest terms. So to get another equivalent fraction, I'd have to multiply this. This case, I'll just multiply by 2. So I get 22 over 30. So this next part here involves the adding and subtraction of fractions. And to add or subtract a fraction, we need to be able to have the same size pieces to be able to add or subtract. Because adding and subtracting essentially is just counting. So if I want to count the number of pieces, I have to have the same size piece. So I need a common size piece. In this case, what I can do is I can actually chop this fraction up into 12ths. And if I do this into groups of 4 here, I end up with 12ths. And to get groups of 4, I'm going to multiply by 4. So that's going to give me 8 pieces that are shaded. And I'm going to multiply by 4. And that's going to give me 12 pieces total. So that ends up giving me basically 8/12. In this case, I'm going to take that quarter piece and I'm going to divide this up into thirds, or groups of 3. And groups of 3, groups means I'm multiplying. So I'm going to multiply by 3 and multiply by 3 to get the 3 parts shaded and the 12 parts that make up the whole. Now at this point, I have the exact same size fraction pieces. So now I can just add them together. So I have 1, 2, 3, 4, 5, 6, 7, 8 here, 9, 10, 11. So 8 plus 3 gives us 11. And the denominator represents the size of the fraction. And the size of the fraction is 12ths. So I need a common denominator in order to add or subtract fractions. Here I have 2 6 plus 1/4. The common size piece of 6 and 4 is going to be 12. So again, I can just slice this up into 12ths. That means I have groups of 2. So it means I multiply by 2. Here I'm going to do groups of 3. So groups of 3 means I'm going to multiply by 3's to get the 3 shaded pieces on top and the 12 pieces that make up the whole. So here I have now 4 and 3. So this is going to be, I'm just going to write it down here, 4/12 plus 3/12. Well, that's going to equal 7. And I don't add the denominators because, again, the denominator represents the size of pieces. The numerator counts the pieces. The denominator tells me how big those pieces are. And those pieces do not change size. So we end up having 12ths here, 12ths here, 12ths here, and our final answer is the same size 12th piece. So when you do this, I would like you to show these multipliers to get the common denominators. So in this case here, to get the common denominator of 20, I can multiply by 5 and 5. So 3/4 ends up being 15/20. I can multiply by 4 and 4. This gives me 4 pieces of size 1/20. And now, since I have the same size pieces, or a common denominator, I can add the numerators together to get 19, and I stay with the same size pieces. So again, if I change the denominator, that means I change the size of the pieces. And that's not what's happening when I count or add these together. Okay, so here the common denominator is going to be, it looks like the common denominator is going to be 110. Because if I take a look at what the factors are here, I have 11 times 2. Here I have 11 times 5. They share a common factor of 11. So I can just multiply by 5 here, multiply by 5 here. And that's going to give me 40 over 110. If I do multiply by 2 here and 2 here, that's the missing factor on this side is 2. The missing factor on this side is 5. And they share a common factor of 11. So we don't need to reuse that common factor of 11 to get a common denominator. So we end up with 6 over 110. Now I have a common size piece, so I can subtract those pieces. I do not subtract the denominators because even when I subtract, the size of the pieces do not change. So I'm going to keep my common denominator that I had when I subtracted.